Hello, everybody, and welcome to reInvent 2019. My name is Doug Booth, and I'm a Principal Business Development Manager for AWS. I've had the unique opportunity to work over the past 3 years with Amazon.com and Thomas Park from Business Data Technologies in their migration off of Oracle to a world of database freedom. In our agenda today, we will be discussing the enterprise database migration. We'll cover the Amazon legacy database infrastructure. We'll cover some of the reasons to migrate, and also discuss the migration strategies along with some lessons learned. We'll also cover some specific public case studies that we've produced to help others in the audience see the different ways teams at Amazon are leveraging AWS database services. Now, before we get any further, we want to show just a really quick brief video here.
The AWS services are really important from a security perspective. Our Oracle environment was not able to scale to meet all of our demands.
Relational databases were a great technology in the 90s when they really came to the fore in the tech industry, and Amazon used them very successfully many years.
Today, we shut down the final Oracle database that used to run our consumer and digital business.
In that transition that we made to use AWS, we've gotten huge advances in availability. The site's more robust. In scale, we've gotten advances in lower latency, especially managed services, critical services that move to NoSQL stores like DynamoDB.
Do we have a permission to shut down the database?
Well, are we going to do this?
Yes.
Yes?
5, 4, 3, 2, 1.
All right.
Outstanding. That was great. So with that, I'll turn it over to Thomas Park.
Thank you, Doug. As Doug stated, my name is Thomas Park. I've been with Amazon for almost 8 years. I started with AWS and later SA team in Virginia, and then another team in Seoul, Korea, before joining the consumer side. In 2016, I joined Amazon's consumer business side in order to oversee the migration of thousands of Oracle database migrations. Today, I'd like to share some of my learnings and how so many Amazon.com teams were able to migrate thousands of Oracle databases. Before I start sharing my story about database migration, let me first share with you about some Amazon.com history and how we ended up having so many Oracle databases. As you know, Amazon.com started its business in 1995. When you take a look at this website, most of you would think that this website would need some help. In fact, a lot of help. Although the website was not the most innovative, the backend architecture was one of the most advanced systems. We had web applications that were taking orders online. Then these orders were stored in our centralized database system. Once the items were shipped, we would then process the payments by integrating our bank with our customers' credit card companies before we complete the payments transactions. In 1995, this was an innovative architecture. However, we started to have issues with our original architecture. More and more customers started to order online. More database processing power was needed. And these old orders sometimes started to slow down. And we were experiencing some outages. These unexpected outages not only impacted our customers' ability to order online, but also stop us from shipping already ordered items and processing credit card transactions. So we had to change, specifically our architecture. We decided to break up this single monolithic architecture into multiple services. Each service will have its own database so that the service and database can independently scale. Ordering service will have its own ordering database. Payment service will have its own payments database. By decoupling the architecture, we were able to scale and troubleshoot issues faster and to contain the outages by each service level. However, we found that going from single monolithic architecture into multiple service-oriented architecture didn't really address our relational database scalability issue. We still had to add more databases in order to scale. You see, when you have a relational database and it reaches 100% full due to data volume increase, you will run into vertical scalability issue. We had to address these challenges and implement different techniques in order for us to scale our databases. One of these techniques is called database sharding. This is how it works. When a database is 100% full, you will maintain a tracker in order to direct your application to store data into a different databases. In this diagram, an application is configured to store customer data 1 and 2 in database shard 1, and customer data 3 and 4 in database 2. This method was a convenient way to store additional transaction data without changing your data model and your data storage infrastructure. However, we found that as we were increasing or adding more databases, the operation costs related to them also increased significantly. By 2017, our OLTP databases had nearly 7,500 OLTP databases around the world with over 75 petabytes of data. These systems were processing daily not only the millions of orders, payments, fulfillments, but also the related data. Hence, these systems could not have any downtime. So how big is a petabyte of data? If you pile a stack of DVDs as high as a 55-story building, the size of the data in these DVDs equal to a petabyte of data. Similar to OLTP system, our legacy Oracle data warehouse system was massive. Just for the DW, or data warehouse system, we had over 50 petabytes of data, 75,000 data warehouse tables, and it was processing 600,000 jobs on a daily basis. Over the 20 years since the data warehouse system was built, number of Amazon teams were publishing and consuming their data every day using this system. Now, Doug will talk a little bit about why we had to migrate these systems.
Thank you, Thomas. So let's talk about some of the reasons Amazon.com decided to migrate. So as we talk about reasons why, first, let's talk a little bit about a few of the requirements. First, they include service availability, data availability, and migration time. Service availability was required to operate at scale. Data availability needed to be consistent, and migration time needed to be done with little to no downtime. That's a very challenging task when you're Amazon.com. I don't think you come to the website too often and where it says it's down for maintenance. It's always running, right? So as you dive deeper, here's some of the primary reasons Amazon came to AWS and said, we're going to do this. First, Amazon had a scalability risk, and it was due to both data volume increases and global market expansion. Second, there was also some latency risks due to data volume and transaction rates were increasing. Amazon's a very diverse organization. Alexa, video. There's many different organizations, all latency sensitive. Third, there were actually cost risks due to hardware and software, and there was challenges with availability, and we were facing price increases on hardware. Fourth, we had availability risks that were simply due to old code and legacy architectures. They just hadn't been updated. And finally, fifth, there were operational risks due to hardware provisioning. It also was very difficult to manage, and it took a lot of time and resources to deliver the capacity. And yet, with all of that effort, there was still a high risk of failure due to these volumes. The scaling issues were actually broad. One example, we had one team that runs the workflow system, our herd workflow. There's a case study out on the public reference site about them. They were facing 60 weeks to scale for a peak event like Cyber Monday, Black Friday. And now we have Prime Day. So even with scaling complete, we were still at risk of failure due to those high traffic demands around the globe. The transaction rates continued to climb, and the business continued to expand. So Amazon never moves slower. And working for AWS, they bring a lot of interesting and challenging requests that they would like help with. One of the things was latency, and we really needed to find new ways to improve latency, but do it on 2 times to 4 times the traffic. That's an incredible increase. Our customer was also managing 75 petabytes of data, and it was growing exponentially. To me, that's a lot of data. I don't know about to the audience. That might not seem like a lot of data to you. It might seem like a lot. We see it as a lot of data. It's very expensive and time-consuming to administer and manage that much. And yet, with all of that time spent, still at risk of failure. Now, after migration, we started taking some results and looking at teams, and we saw some teams were seeing 40% improvements in latency after migration. That was without really tweaking anything or optimizing anything heavily for performance. That was just right out of the gates. And they used AWS managed database services like DynamoDB and Aurora to be successful. They're managed services, and these services take care of a lot of the heavy lifting and updates and patch management that take a lot of time and effort at this type of scale. One of the challenges with hardware and pricing is we were ordering so much, we would deplete some of the manufacturer's supply chains, and it was tough to get crisp timing on delivery of equipment needed, and it took a massive effort of people to cut the POs and receive and stand up and do all of this work. This was not working for Amazon.com. The software pricing and vendor tactics were also a challenge. They were difficult, the relationships were difficult, and again, costly to manage. There was also some availability and operation risk. This is a really critical point here, is Amazon needed the ability to scale both up and down with their databases. And in the case of something like a peak event, dramatically and many times over their normal rate. Amazon had hundreds of people managing and scaling legacy systems, and even with the best support from the manufacturers with us on these peak events, still at risk of failing and delivering a poor customer experience. We also had requirements around the data need to be designed for 100% availability, and data needed to be consistent 100% of the time. So very challenging tasks in an enterprise-style migration. Which brings us to Prime Day. You know, it used to be that we had Black Friday and Cyber Monday, and we had some teams that were facing 60 weeks to scale, but hey, here's another event, and it's about halfway through the year. So now teams had less time to prepare for these peak events because there were more of them, which I think is really interesting. It shows what you can do. It wasn't a holiday, It's actually a day in the summer that became one of the most successful retail events in history. To get a view of the scale that we addressed, in 2015, Amazon held the first Prime Day. It really has not been around for that long. During that year, Amazon sold 34 million products. They did this across 9 participating countries over a 24-hour period. But then fast forward to 2019, 175 million products sold across 18 countries over a 2-day window. It was the biggest retail event in Amazon history, and it beat out Black Friday and Cyber Monday, and it was in the summer. Normally, people think that kind of thing would have to only happen during the Christmas or other holiday seasons, but it turns out that wasn't the case. It's a very successful event. Now, with that, I'd like to bring Thomas back up, and he's going to talk about some of the migration strategies and lessons learned in the project.
Thank you, Doug. So, my responsibilities when I first joined the consumer business in 2016 included operating and managing Amazon.com's data warehouse system, thousands of OLTP databases, as well as leading the deprecation and migration of all these databases to AWS. However, at that time, my team was keep adding more Oracle databases, not migrating. We were really struggling to scale our databases. And we were constantly worrying about system failure due to lack of free disk space. We were really in trouble. We needed to change immediately in order to achieve our migration goal. As you know, we just announced in October 2019 that Amazon's consumer business completed this massive migration of nearly 7,500 OLTP databases from Oracle to AWS. This migration was huge, nearly 75 petabytes of data across many Amazon teams, including Alexa, Prime, Kindle, and much more. But how do you deprecate and migrate all these databases to AWS without any downtime or loss of data? Today, I would like to share how all these different the Amazon teams migrated their databases and lessons learned from our experience. When we first started the migration project, we lacked visibility of our database and their ownership. See, databases were created and consumed by many different teams without any centralized tracking mechanism. So we had to increase our visibility of our legacy Oracle database infrastructure, database schema, as well as application dependency. In our case, a single database can have thousands of different tables, and that tables can be updated and consumed by many different service teams. So who should really take the ownership of migrating this database? The creator, the consumer, or the DBA? That was a huge dilemma. One way to identify the database user is to track database connections. We collected all the database connection log and started to parse and count the connection information using AWS EMR clusters. This visual diagram allows us to answer questions like, how many Oracle databases do I have today? How many Oracle databases do we launch today? Having this visibility of database infrastructure allow us to define KPIs and success metrics to track the migration effort. Once we had a better idea about the number of databases to deprecate and to migrate, we found that we also needed more detailed information about database schema, such as table usage. We also needed to increase our visibility of database tables in each database. For example, we had to answer questions like how many database extract jobs were running in a single database, how many read or write operations were running on a database. Soon we started to collect additional information, such as database CRUD operations, create, read, update, and delete operations. The picture on the right is a visual diagram of Oracle database MView dependencies. Oracle MViews, or materialized views, allow data replication from a single database to multiple databases. By tracking these MViews and table-level replication dependencies, we were able to track database migration status by each database table. Gaining a solid understanding of our database infrastructure and table dependencies also allow us to realize that we needed to increase our visibility on application dependencies. We wanted to know all the applications that were using the database and map all application SQL statements to a database infrastructure and tables. There were many different ways to do this, but here's one tool that we created. We created Java library wrappers to track all SQL execution of database queries for centralized analysis. We use Amazon Kinesis and Elastic Cache to capture and analyze SQL queries that were initiated by different applications. By monitoring these SQL queries, we were able to answer questions like, what application was using which database tables? This type of visibility allowed the development team to plan the database migration, but more importantly, software engineers starting to gain more confidence about the database migration plan. By increasing our visibility of our database infrastructure, schema, as well as application dependencies, we were able to remove uncertainties and doubts about database migration. With any challenging endeavor, you will always need executive support. In our case, we needed to accelerate such valuable support, as deprecating and migrating a number of databases impacted many different stakeholders throughout Amazon. During our migration journey, we found that many executives actually never tracked nor knew how to track database migration project. We leveraged AWS account and product teams to engage and build trusted relationship with our executives. And we also identify internal AWS advocates and people interested in AWS technologies to ensure that the executives' concerns about the migration project was properly addressed and mitigated. Finally, we also built some tools and data dashboard to inform and track database migration project progress by each executive. These tools and dashboard also provided our CEO to review each executive's database migration status on a monthly basis. I have to say that when an executive receives a call from the CEO about his or her database migration status, it surely motivates and accelerates teams to focus and put the migration project on priority. Here's an example. Our database migration dashboard included this chart, which shows the number of database migrated by month over month. Since the launch of the dashboard, you can see a significant jump in the number of migrated databases within 2 months and continue upward trajectory thereafter until the conclusion of the project. We found that many teams immediately leverage dashboards information and tools to identify database dependencies and to shut down unused and unnecessary databases. Even after we increase our visibility and accelerate executive support, we still had to confront and address FUD and real technical issues. FUD is fear, uncertainty, and doubt, and it is different from technical issues. We face a lot of resistance to migrate databases, especially from our own Oracle DBAs. They wanted to add more databases to address operational issues, whereas we needed to deprecate and migrate these databases. I realized that gaining Oracle DBA support was critical for our database migration. Many Oracle DBAs expressed a lot of doubts and fear about migrating databases. However, these doubts and fear, in fact, did not relate it to technical or operational needs. You see, when you have a people who dedicated their entire life and built their career on Oracle technologies, Oracle database migration was a huge curveball. There was a huge gap between their professional career and our migration goals. So we focus on providing DBA career path and training opportunities. I say to them, they will become experts in both legacy Oracle database operation and new AWS database technologies. They will play a critical role in the biggest Oracle database migration in the world by demonstrating their expertise in both legacy and cloud-based technologies. By addressing their FUD and gaining their trust and support, our DBAs were critical in resolving real technical issues and accomplishing our goal of migrating all the databases. We also found that having an environment of force multipliers was key to our successful database migration. We basically enable the enablers. At the initial stage of the migration, we noticed that many teams were making similar mistakes over and over again and experiencing common blockers. Although we had workarounds and solutions for these blockers, many teams were not aware of it. Having an environment of force multipliers, we were able to enable the enablers by creating and sharing reference architectures, best practices, design patterns for database migration. In the next few slides, I'm going to provide some examples of force multipliers that we created. Here's one such reference architecture that we created and shared with our teams for migrating Oracle database to another relational database, Postgres. We have a legacy Oracle database on the left that are being migrated. To target database, in this case, Postgres, using database migration service. We have a data validation service on top to validate all the migrated data from source to target. In the far left, the service calls are separated into two. One, for the service calls that have not been migrated, and one for the service calls that have migrated. This is a typical pattern for migrating Oracle database to Postgres database. However, we ran into multiple issues when our target database, in this case Postgres, failed before all the migration could be completed. So we created another Oracle database in the far right to replicate the Postgres database using DMS. The purpose of this replication is to handle fail-back situation. A fail-back situation can occur when target Postgres database fails before all the data and tables have migrated. In order to prevent any service disruption, we set up another Oracle database, in this case, RDS Oracle in AWS, and replicate change data capture, which is CDC logs, from PostgreSQL back to RDS Oracle databases. Another example of creating force multiplier is writing blogs or maintaining wiki pages to share best practices, challenges, and solutions. Here's an example of a blog post that was published back in 2018. This blog contains some common challenges that our team faced during the migration. You can see there are many common challenges, but today I would like to go over just one as an example. One common challenges that we face as we migrate Oracle database to Postgres was data type difference. In this example, we noted that Oracle was more tolerant in treating empty string and null data. Let me tell you what I mean by that. When I insert an empty string, Oracle stores it as null. And you can actually query it using predicate where name is null. And both values will display. On the other hand, Postgres doesn't display the row with an empty string when I query using the same predicate where name is null. To find the row, Postgres, I have to query using equal sign and look for the empty string in a predicate. We learned the difference during our data validation test. Some teams spend several hours or even days to troubleshoot this type of data validation issues. By sharing common database migration challenges and solutions, we were able to overcome them and accelerate migration time. Another challenge that we had to overcome was how to migrate services without any downtime. Here's another reference architecture that we created to address this challenge. In the previous slide, I talked about separating service calls to both Oracle and Postgres. Probably many of you have wondered, how did you do that? Well, here's one way to do it. We leverage AWS DynamoDB and cache layer, Elastic Cache, to store mapping information of each application module to a database engine. So, for example, application A is mapped to PostgreSQL, and application B is mapped to Oracle. We also created a connection pool with dual connection to both Oracle and Postgres databases. At runtime, each application module would determine which connection to execute the SQL based on the mapping information. In order to keep data continuously syncing between the tables in both Oracle and in Postgres databases, we also set up AWS DMS replication. So for example, when application B is inserting a record in Oracle table B, AWS DMS will capture the change and replicate in Postgres database table B. Hence, both table B in Oracle and Postgres databases will be in sync. Similarly, when application A updates a record in table A in PostgreSQL database, AWS DMS will capture all the changes and replicate them to our Oracle database. We set up this DMS replication from Postgres to Oracle in case the Postgres database fails before we are ready to cut over all the applications. This architecture allowed the software development team to stagger their database migration by application modules. The previous architecture was focusing on migrating Oracle database to another relational Postgres database. But you may also ask, what about migrating Oracle to DynamoDB, which is NoSQL database? As you know, migrating relational Oracle database to NoSQL database will require you to redesign your data model. Many software development teams develop dual write capability in order to overcome that challenge. A dual write capability can insert a new transaction asynchronously to DynamoDB. This capability allows us to validate our DynamoDB data model before we can cut over our application. Once we confirm and finalize our DynamoDB data model, we migrated all the missing transactions from Oracle to DynamoDB using a tool called data backfill. We developed this data backfill tool in order to run in the background for a while, sometimes for months, depending on how much old data from Oracle we had to migrate to DynamoDB. We also created retry backfill process using Amazon SQS. Soon after we started using our backfill tool to migrate our Oracle data to DynamoDB, AWS DMS team released a new feature to support Oracle to DynamoDB migrations. So today, you do not need to actually create your own backfill tool. You can simply leverage AWS DMS to improve data backfill and minimize downtime. Finally, I would like to emphasize the importance of working with the AWS team. During this journey, AWS team worked closely with our executives, engineers, DBAs, and program managers to remove technical blockers, develop specific database solutions, and help us transform our legacy Oracle database infrastructure. If a company like Amazon can move so many Oracle databases used by so many decentralized and globally distributed teams to AWS, it really is in the reach of most of enterprises. AWS team is a committed partner, and they're very flexible, as well as providing very reliable and scalable database solutions. So now I'm going to hand it over to Doug, and Doug will share some benefits that we realize.
Thank you. All right, thank you, Thomas. Now we're going to cover some of the benefits and some of the outcomes from the effort. Thank you for sharing us some of your techniques and how you actually did the migration. So Amazon migrated nearly 7,500 databases. And they did most of the migration to Amazon RDS and Amazon Aurora. We had 303 critical services that moved to DynamoDB. And through that, Amazon did actually discover database freedom. Some of the outcomes: reduced operational costs, improved latency, reduced scaling efforts, and increased innovation. Many of the services we've mentioned today are managed services. So a lot of the keeping the lights on, the management, that goes away, and it allows you to focus on building solutions that matter to your customers versus having oceans of people just scaling it to keep it alive. Many of the teams actually used data migration service. You'll also hear it referred to as DMS and schema conversion tool, also referred to as SCT. From a call to action, if you haven't been exposed to these yet, I encourage you to take a look. Now, purpose-built databases allowed Amazon to choose the right tool for the right reasons. One size for all no longer fits all of our different use cases. It just doesn't fit. Now, when we took a look at some of the outcomes, it was pretty staggering. So what we're going to talk about now is, hey, for this investment, what's on the other end of the rainbow? Can I get these improvements? And the answer is yes, and we're seeing them left and right across hundreds of teams. So we've been seeing 40 to 90% operational cost savings. We've seen latency improvements of up to 40%, but on 2 times to 4 times the traffic volumes. At Amazon scale, that is miraculous. I hope you'll consider that, because you could have that for yourself as well. We also saw a reduction of 10x in administrative overheads related to database. That's remarkable. These are all elements that contribute to operating efficiently and driving the pace of innovation, because now we're not paying for things that we don't want to pay for. We want to pay for things that drive innovation. Let AWS databases take on some of that heavy lifting and do that maintenance for you so you can innovate. So we're going to go over a few keys to success. First of all, purpose-built. Pick the right use case, pick the right database. It can save you lots of time, effort, and precious capital. I'd also say the full leadership support's very important, and you could see from the graph earlier that really helped everybody stay on the same page. It helped maintain the integrity of the project, and it kept everybody very aware of who was doing what, who owned what, when it was due by. We also did a lot of training in a lot of different forms. We did some self-paced and class-based trainings, but actually you can partner with your account team. So if you have an account manager and a business development manager, along with SAs, technical account managers, and CSMs, we did a lot of brown bags, deep dives, immersion sessions on everything from how to migrate, but also how to operate, how to prepare for a peak event that's outside the normal. And we did that, and we did it as AWS with Amazon.com, and found that it was very successful. You have the same access that these teams did. We support Amazon.com the way external customers are supported, so you can have this too. The relationship between our companies was very important. We are different companies. We have different CEOs. So keeping everybody on the same page was very important, and it ensured our leadership alignment, roadmap clarity, and operational readiness were all important factors that everybody stayed focused on. Now, another key was an internal community that we created called Shackleton. And Shackleton was a group of people that we just made a request to through a distribution list we created, and we invited people in. And what they would do is they would just throw a question out there. I'm having this problem doing this. And the team would actually, volunteers would say, yeah, I faced that too. Here's the solution, here's the code. And so we found even a little community effort actually helped move the ball very far. There were a lot of people, it turns out, that were passionate about building in a new way. And then last, we documented some of the wins, and we tried to evangelize them internally, but some of them actually got converted to external stories that we could go out and share some examples. And so we'll go over a few of those now. Now, what we've done is we created, up on the link on the screen there, an innovators page that consolidates all of the case studies in one area for you to review. So case studies cover a lot of different areas of Amazon, and some of these names you actually may be familiar with. So AFT is Amazon Fulfillment Technologies. If you've ordered something from us, it definitely goes through them. You can learn how they use Aurora to manage inventory. You can also learn how Business Data Technologies leverages Redshift for analytics at scale. And you'll even find our story, the enterprise database migration case study, is also up there. We have a few more. One of them includes our wallet service. Our wallet service increased performance of its business-critical payment services with DynamoDB. And they did it while increasing elasticity and reliability, but to make it even cooler, they did it with no downtime. That's remarkable. Now, as we look out further, Prime Video has done incredible things with a number of our database services, and they migrated billions of rows from Oracle to DynamoDB while increasing their elasticity and reliability, no downtime. But we also have advertising that uses RDS to simplify scaling so they don't have to address or provision against future spikes. Now they just pay for what they need when they grow. And coming toward the end of this, we have a buyer fraud detection service. We have a lot of things we need to look for in the fraud area. And they leveraged the database migration service to migrate to Aurora, which allowed them to simplify all of their scaling operations and reduce operational costs. They're getting the same performance they got on Oracle at half of the price. That's a pretty interesting number to work with there. And it could be even optimized further. You'll also see how Items and Offers team increased availability by 10x with DynamoDB, no downtime during the migration. And then finally, we have a team known as the Financial Ledger and Accounting Systems Hub team. We refer to them fondly as the Flash team. They leverage both RDS and DynamoDB. And they do this so they can handle any level of transaction volume that we may face. Sometimes we don't always have an exact number. The other really interesting part of this story, and I hope you'll look into this one further, is they reduced their latency 40%. They cut their administrative costs and overhead by 70% as well. Those are remarkable outcomes. So if you're thinking that maybe it's too expensive or too costly or there's too large of a list of reasons why not, on the other end of the rainbow for that investment, a lot of that stuff goes away and you capture those cost savings going forward. Think about that over 10 years, what the cost of that would be if you didn't take that action. But also think of it another way. If you're competing against somebody else that does have these capabilities, how well will you do? These are some really unique capabilities that Amazon now possesses because they picked purpose-built databases. So I hope you'll consider that. Now, we want to make it easier for you. And this can be a complicated topic. So we put together some playbooks that will help you through this process. I hope you'll snap some pictures of this one, because this can really accelerate your progress moving forward. We have migrate from Microsoft SQL Server to Amazon Aurora MySQL, all the way down to migrate from Oracle to Amazon Redshift. Did you know you can actually go from Oracle Data Warehouse to Redshift with DMS? Fascinating. It works very well. I hope you'll try it. Try a proof of concept. Look for that low-hanging fruit opportunity. Give it a try. You might be amazed with the outcomes. It could help fund your innovation. It could help fund headcount. And maybe I'll leave you with one thing here, is that what if just by moving to AWS databases, you could help fund IT? We've talked about some remarkable cost savings here. So what would you do with those savings if you could capture those savings? How would you innovate on behalf of your customers? I think they're all very interesting questions. Now, finally, we appreciate that everybody's taken so much time out of their busy schedules to spend a week with us here at reInvent. But we really don't want it to stop here. So we hope you'll keep reinventing with resources from our training team and encourage others in your organizations to train and get the new skills that the cloud world demands. Having the experience in the legacy world, and as Thomas stated, also having the experience in the new world of AWS databases will help make you even more valuable. The options for databases are many, and it's growing. And it can be tough to sometimes navigate these, so we want to help make this a little bit easier. So we've launched a new database overview course, and it provides a foundation in 4 hours. Now, there's also introduction videos and primers on 7 of our AWS database services. And then if you want to take it further, I would argue that validating your experience with industry-recognized certification is that next step. You can transform your career. Many of these certifications are new. When they're new, that means fewer people have them, and you will be more unique. So I hope you'll consider certification as a part of your career path, or if you're managing teams, encourage them to learn the new skills. It's remarkable what you can come up with when you build on AWS. Now with that, I'd like to bring Thomas Park back up here, and I want to thank you all for participating in our session. I hope we have provided you some information and tools to help in your journey to AWS, and we hope you'll complete our survey in the session app. Thank you for coming out today. Thank you for participating, and have a great reInvent, okay? Thank you.
Thank you.
Good job.